Hi, it's Mr. Royks. I'm going to take you through a practice problem that is very similar to number 6 on the worksheet that I asked you to finish from class. And so this is a different problem, but you're going to solve it the same way. So it says nitrogen gas and hydrogen gas combine to form ammonia according to the equation below. And it says if 3.2 liters of nitrogen at 23 degrees Celsius and 2.05 atm is combined with 3.2 liters of hydrogen gas at 20 degrees Celsius and 4.2 atm, then what mass of ammonia gas would be formed, what is the limiting reactant, and what is in excess. So the first thing that we're going to want to do while solving for this is we're going to want to balance this equation. So I'm just going to make it bigger so we can write on it. And so to balance this equation, we're going to need a 2 in front of the NH3 and then a 3 in front of the H2O. Okay, so that's the first step. The next thing that we're going to want to do is, in this particular case, we're going to end up having to use PIV-NERT. So we're going to use the ideal gas law. PV is equal to nRT. And we're actually going to do it twice. We're going to do it once for the nitrogen, and we're going to do it once for the hydrogen. And the reason why we have to do it twice is because the gases are at separate conditions. So we're going to have to do it separately for each. Our end goal in starting to solve for this is going to be solving for the number of moles of each gas. So remember, if we go back up to our balance equation, for every 1 nitrogen, we need 3 hydrogens to produce 2 NH3s. So sorry, apparently they're testing the fire alarm system, so I'm not in danger if you hear the fire alarm. So here we go. When we're dealing with this type of problem, what we need to look at is we need to end up solving for how many moles of each of these types of gases do we have, so we can finally determine how much NH3 or ammonia we can form. And so that's really what they're asking for about the limiting reactant and the excess reactant. So again, going back to an example in class, if I told you I have 1.0 moles of N2 and I have 2 moles of H2, and I'm trying to figure out how much NH3 I can form, right? All we have to do is look at the ratios. And so the ratio between the N2 and the NH3 is there are 2 NH3s for every 1 N2. So if I have 1 N2, I can produce 2 NH3s. And when I say 1 and 2, we could be talking about moles, because I mean, we're really not talking about single molecules of N2 and single molecules of NH3. And if we look at the same thing here, the ratio of H2 to NH3 is for every 2 NH3s, it's going to require, 3 H2s. So if I have 2, right, I'm going to end up with 4 divided by 3, and I'm going to end up with 1.33 NH3s. If I gave you 1 mole of N2 and 2 moles of H2 and asked you how many moles of NH3 you can form, right, based on those two values that we just showed, the maximum amount you could form is 1.33 moles of NH3. You can't form 2 moles of NH3 because you wouldn't have enough of the H2. So in this case, right, the H2, because it produces a smaller number of moles, would be called the limiting. And the N2 would be in excess. We'd have extra nitrogen gas, some of which would not react. So when we're solving for this problem, we're really going to do the exact same thing, except we're going to use PIV-NERT to figure out the number of moles of each gas in order to figure out which is limiting, which is in excess. So that's what we're going to do. We're going to plug the values into Pivnert right now. So for the N2, I'm solving for moles, so it's going to be N is equal to PV divided by RT. My pressure is 2.05 ATM. It's already an ATM, so we're all set with that. My volume is 3.2 liters. And my R value is going to be 0.0821. My temperature, need to make sure I add 273 to that, so that is 296. And I will solve, and that will give me the number of moles of N2. And I get 0.269 approximately moles of N2. And I'm going to do the same thing with the H2, moles of H2. So I'm looking for N, and I plug in my values. It's going to be 4.2 ATM times my volume of 3.2 liters over my gas constant 0.0821 times my temperature in Celsius, which is 293. And I will solve. And what I get for moles of H2 is 0.558 moles of H2. Now, what I'm going to have to do is I'm going to have to do basically the same sort of thing that I did with the example I gave before, and I have to look at now the ratios between the N2 and the NH3 and the H2 and the NH3 to determine which is going to give me more moles of NH3. So I'm going to take my 0.269 moles of N2, and I'm going to multiply it again by that fraction, and we could do it in dimensional analysis as well. Maybe I'll show it in dimensional analysis, which is the same as multiplying by my fraction. It is 1 N2 for every 2 NH3s. So I'm basically multiplying my answer by 2, comes out to be approximately 0.54 moles of NH3. Now I'm going to do the same thing over here with my H2. So I'm going to say 0.558 moles of H2. I'm going to run out of room, but I'll make this a little bit smaller. Move that over slightly. All right, and again, now my ratio here is there are 3 H2s for every 2 NH3s. So I'm going to multiply this by 2/3. And I get 0.37 moles of NH3. So which is a smaller value? This or this? Hopefully you chose this. If you did, you chose correctly. And so that is the maximum amount of NH3 I can form from combining these two gases. Now, the final part of this question is how much or what was the mass of the gas formed. So I'm going to take that value here, moles, and multiply it by the molar mass of NH3. So I say 0.37 moles. The molar mass of NH3 is 17 grams per 1 mole. And when I multiply that through, I'm going to get an answer of approximately 6.27, 6.3 grams of NH3 ammonia. So there is my answer to the grams of ammonia, 6.3. My limiting is going to be the hydrogen gas, and my excess is going to be over here. My excess is my nitrogen. So we can solve problems like this. Again, there is some work involved. It's not, I never said it was going to be easy, but I think it's very doable, and I think you guys are all capable of this. So take this same plan, apply it to number 6 on the worksheet that I asked you to do from class, and you should have no problem coming up with the answers. All right, thanks for watching. We'll see you in class.